Hello everybody. Let's talk today about finding the equation of a quadratic. So we know various forms of quadratics. We have factored form, and factored form would look something of the lines, that's an S, and that's a T. So A bracket X minus S, X minus T. Of course, these are our factors. We can have vertex form, which could look like this. And then lastly, we have standard form. So what we're going to look at today is, given different information, can we actually find the equation of our quadratic? And specifically, if we're given information that's either from factored form or from vertex form. So these will be the two that we'll be using today. Okay, so here we have a parabola. It opens down, and it wants us to express the equation in factored form. So factored form, the nice thing about factored form is it tells us the x-intercepts, or the zeros of our parabola. So the first thing that I'm going to do is I'm going to look at my parabola and try to determine where my x-intercepts or zeros are. Now, they're not exact here, but they're pretty darn close. So let's say we have one x-intercept at 1, 0, and we have the other x-intercept at 7, 0. So what we want to do is put those x-intercepts back into our equation in factored form. And the way that we do that is we substitute x equals 1 is our first x-intercept, and x equals 7 is our second. And we want to rewrite both of those equations so that they're equal to 0. Once they're equal to 0, that's what goes back into our bracket. So in order to do this, I'm going to subtract 1 from each side. So I have x minus 1 equals 0. I'm going to subtract 7. X minus 7 equals 0. So what this means right now is I have y equals a bracket x minus 1. So this part goes into my first bracket. And x minus 7, this goes into my second bracket. Okay, so we're looking pretty good. We already have our zeros back in. A lot of times we use kind of a cheater method. We say, well, if it's the x-intercept is at a positive 1, then when it goes back into the brackets, it must be a negative 1. If my x-intercept is at a positive 7, then when it goes back into the brackets, it's a negative 7. So the cheater method, of course, is just that we change the sign. Okay, well, we're almost done, except that we have this a value out front, and I need to figure out what that a value is. So in order to do that, I'm going to have to pick a point off of my parabola that I have not used yet. So I've already used the x-intercept, so I can't use that one again. But I'm going to go up here. I'm going to use my vertex. So my vertex right here is at 4, 5. Okay, so I'm going to use my vertex to help me figure out my a value. That vertex is a point, so it has an x coordinate and a y coordinate, which means I can take that back to my equation, and I can replace all my x's with 4s and all my y's with 5. And so what we get is 5 is equal to a bracket 4 minus 1, 4 minus 7. 5 is equal to a bracket 4 minus 1 is 3. 4 minus 7 is negative 3. So 5 equals 3 times negative 3 is negative 9. So you multiply those numbers together. Then, of course, put them in front of the variable. And then let's divide each side by that negative 9. So a equals negative 5/9. And that will help us complete our equation. Our equation must be y equals negative 5/9 because that's our a value. x minus 1, x minus 7. Okay, so let me just do a quick little check. Just to make sure that things look and appear that they are correct. So first off, we have a negative sign in front of our a value, and the parabola opens down. So that means, of course, that the negative sign does show that the parabola opens down. I can see the parabola opens down, so we must be correct on that. And then this x minus 1, x minus 7 tells me I have an x-intercept at 1 and at 7, which I also have. So this equation looks good. Okay. Let's take a look at the next example. Sometimes they don't give us a picture, but that's okay because they'll tell us information. So in this case, determine the equation of a parabola that has x-intercepts. So right there, they're telling us some good information. We have x-intercepts at 3. Whoops. X-intercepts at 3 and at 7. So 3, 0, and 7, 0 are my x-intercepts. And then it has a y-intercept at 8. So there's another good piece of information. That's our other point. So a y-intercept is at 0, 8. That's a y-intercept. So this is going to be the other point that we're going to need. All right, let's begin by taking these x-intercepts and setting x equal to them and then putting it equal to 0. So I'm going to have to move this 3 to the other side, subtract 3, x minus 3 equals 0, x equals 7, subtract 7 from each side, x minus 7 equals 0. So y equals a bracket x minus 3, x minus 7. So there we go. We have our factors. We have our x-intercepts back into the brackets. Notice it's just a change of signs. And now I'm going to use my other point to figure out my a value. So wherever there is an x, I'm going to put a 0. And wherever there is a y, I'm going to put an 8. And I get 8 equals a bracket 0 minus 3, 0 minus 7. 8 equals a negative 3, negative 7, 8 equals negative 3 times negative 7 is a positive 21. A, then divide by 21, divide by 21. 8 over 21 equals A. Okay, so then let's write our final equation. Y equals A, which is 8 over 21, bracket x minus 3, x minus 7. Perfect. Okay, so just be careful. If they tell you an x-intercept or a y-intercept, that's an actual point. Okay, it's at 0, comma, and then whatever the number is, in this case 8. And they can tell you your x-intercepts, which is great. All that information, of course, helps us when it's in factored form. Okay, but what if it's not in factored form? Oh, no, I guess we're gonna do one more example of factored form. So this is definitely a great chance for you to pause the video, try this one on your own and come back because it's still factored form. The reason why I know that it's still factored form is because they're telling me my x-intercepts again. Whenever you're given your x-intercepts, it's gonna be in factored form. So determine the equation of the parabola that has x-intercepts of 2 and negative 6 and passes through the point 3, comma, negative 10. Pause the video, give her a try, and then come on back. Okay, so hopefully you're back and realize that if I put that positive 2 back in, it becomes negative 2. If I put the negative 6 back in, it becomes positive 6. And now we know it's going to pass through the point 3, comma, negative 10. So y equals negative 10, x equals 3. 3 minus 2 is 1. 3 plus 6 is 9. 1 times 9 is 9. Divide by 9, divide by 9. And so A equals negative 10 over 9, which is awesome. So my equation then is going to be y equals negative 10 ninths x minus 2 x plus 6. Okay, there we go. So hopefully this is resonating with you a little bit. X-intercepts mean factored form. We put those x-intercepts back into our brackets, of course, changing the sign. Then we plug in our point with x and y to solve for a. Okay, here we go. Vertex form. So vertex form looks like f of x equals a bracket x minus h squared plus k. And the vertex of a function is 2 comma negative 5. And the y-intercept is at negative 17, which is 0 comma negative 17. Okay, find the equation of the function in vertex form. So if you have your vertex, 2 comma negative 5, this is your h value and this is your k value. So notice your h value is going to go back into the bracket. So it's going to change signs. So we're going to have y equals a bracket x. That 2 goes back into the brackets, becomes a negative 2 squared. And then your k value stays as your k value, so minus 5. From here, we need another point. So just like before we were putting our x-intercepts back in and then finding our a value, now we're going to put our vertex back in and find our a value. My other point is at 0 comma negative 17. So this is my x and this is my y. So I'm going to go ahead and plug negative 17 in for y. A 0 minus 2 squared minus 5. Excuse me. Okay, so we got to do a little bit of math work here. 0 minus 2 is just negative 2 squared minus 5. And negative 2 squared is 4. So now I have negative 17 equals 4a minus 5. I'm going to solve this equation. I'm going to start by adding 5 to each side, and I get negative 12 equals 4a. And then divide each side by 4. A equals negative 3. Look how pretty that worked out. So y equals negative 3 bracket x minus 2 squared minus 5. And here is my vertex form of my equation. I can do a quick double check just to make sure my vertex is right. So if I was looking at my equation and I pulled the vertex out of it, then that negative 2 becomes a positive 2. And then, of course, the negative 5 stays the same. So 2 comma negative 5 is my vertex. Remember, you can always double check things in Desmos too. So you could put that function into Desmos. And then from there, just check to make sure that the vertex is at the right spot and it has y-intercept of negative 17. Okay, I think one more question. Find the equation of the parabola in vertex form if the vertex of the function is at negative 5, negative 8, and has a y-intercept of 42. Okay. So a bracket x. So I'm going to take this negative 5, put it back inside my bracket. It's going to become a positive 5 squared and then minus 8. All right, looking good so far. Now I have a y-intercept of 42, so 0 comma 42 is my point, which means wherever there's an x, I'll put a 0. Wherever there's a y, I'll put a 42. So 42 equals a 0 plus 5 squared minus 8. 42 equals a 5 squared, right? 0 plus 5 is 5 minus 8. So 42 equals 5 squared, which is 25a minus 8. So there's my equation. Let's go ahead and solve it now by adding 8 to each side. So 50 equals 25a. Divide by 25. Divide by 25. And a equals 2. So my equation then must be, whoops, y equals 2, bracket, x plus 5 squared minus 8. And again, I'll just do a quick double check. If I look at my equation, my vertex I can see it is going to be at -5, comma, -8. Okay, so I mean, regardless if you're finding it in factored form or vertex form, it's all about putting the information that you have back into your equation and then taking a point, subbing that in so that you can solve for your A value out front. Your leading coefficient is what it is. All right, so the best way to figure this one out is to practice it. If you don't mind going to page 57 in your book and practice this a few times. And if you have any questions, of course, just reach out to me. Thank you.